Hi, we're the NASA Psyche Landing System Red Team. To start off with a brief disclaimer, this work was created in partial fulfillment of Rochester Institute of Technology Multidisciplinary Senior Design course. The work is a result of the Psyche student collaborations component of NASA's Psyche mission. The content is solely the responsibility of the authors and does not necessarily represent the official views of ASU or NASA. To start off with introductions, I'm Jacob Samuelson. I'm a dual degree student in my 5th year. I'm an industrial engineering major and an engineering management master's. For roles, I'm the team lead and communication roles.
I'm Grace Maggio. I'm a 5th year mechanical engineering student, and I was one of the systems engineers on this project.
I'm Dennis Lamb, and I'm a 5th year computer engineering student, and I'm the facilitator for the group.
Hi, I'm Jordan D'Alba. I'm a 5th year mechanical engineering student, and I'm an active systems engineer on this project.
Hi, my name is Timian Hiver. I'm currently a 5th year electrical engineering student, and I'm working as the purchaser for the team.
So a little background is that this asteroid was discovered in the mid-1800s, and it was named Psyche. It is classified as an M-type or metallic asteroid, and current data suggests Psyche is likely made of a mixture of rock and metal, with metal comprising between 30 to 60% of its volume. Due to the nature of this project, our team was given a very loose problem statement to work with, and due to the distance between Earth and Psyche, and the fact that no spacecraft has yet visited it, information about the asteroid is limited. With this, our team had to be creative and brainstorm versatile ideas that could cross multiple hypothesized surfaces. Until a NASA orbiter arrives at Psyche in 2026 and is able to observe its features and collect data on its composition, we will not know if our design will be truly feasible.
Here's the mission statement. The NASA Psyche mission is an orbital mission that will not physically land on the intended asteroid, but instead study it from a distance. The original mission will be launching in August of 2022 and arriving at the asteroid in 2026. It is possible that once Psyche is observed from orbit, future scientists and engineers would want to propose a return mission to land on the surface. The Psyche landing system for uncertain terrain is a hypothetical design project that hinges on the idea of going back to the asteroid to study the surface in the near future. Some of our deliverables, our team's role is to design a landing system for future asteroid exploration. By the end of this project, our team will design and prototype a portion of the landing system that will be capable of safely landing on the Psyche asteroid. Some of the key constraints while working on this project include low gravity on the asteroid, the size of the craft that will be landing, the geometry of the landing surface, and the hypothesized materials of the landing surface.
So upon completion of this project, our team will have created a working physical prototype of our lander, which is the 3D printed parts on the left images, as well as a running digital model created in a program we've been using called MSC Atoms. The image to the right is a screenshot from that software. Our solution is a system that will lower within a couple hundred feet of the asteroid surface. It will then be released and guided to the surface by 4 thrusters. Upon contact, 4 struts will absorb the impact force while thrusters on the top of the lander will engage, ensuring the lander remains on the surface of the asteroid and does not float off. Then 4 linear actuators will engage to extend each of the legs as necessary to reach a stable equilibrium point. At this point, the thrusters will disengage and the lander will be safely at rest on the Psyche surface.
For more in-depth information on our work, process, results, and how our project ended, please check out our website to see how our prototype landing on the hypothesized surface. We would like to thank everyone in the NASA Psyche team and Arizona State University for making this project possible. A special thanks goes out to Cassie Bowman and her team for supporting and remaining in close contact throughout the life of this project. Lastly, we'd like to thank our guide, Carlos Berrios, for supporting us throughout our endeavors and pushing our team to be successful across all areas of the project.